Hello everyone, welcome to First Mentor. So let's get started with data science. If you ask me to explain data science in just few words, then I would say it's making sense of data. This is the agenda which we are going to follow. So let us understand what is data. Data can be images, numbers, words or text files, videos, recordings of sounds, maps, etc. Actually, what you see around you, almost everything is data. Unprocessed information or raw information is data. Now, why did I said that? Let's take an example of a smartwatches. And as it helps us to collect the data, suppose it's collecting your data of your blood pressure, diet, calories burned, footsteps. Suppose it's showing up as 5,000 footsteps. Then how useful will be the data for you? Nothing, right? But if you have an information that 50% of this 5,000 footsteps you should walk every day, then these insights are called as data information. Remember, data in its raw form doesn't add any value. Here's where statistics comes in the picture. You extract insights through statistics. Statistics helps you to extract value from your data. That is, value is nothing but information. Now, why data science? New driving force behind industries is data. Virtually every organization has it, and most want to find the ways to use it to help them grow their businesses. Here are a few reasons to go in this field: unbeaten salary, easy to grab a job, growing demands, evolving field. But for me, the most important reason should be adding value to the business because you are playing a very important role here as a trusted advisor and strategic partner to the management. Now, who is data scientist? Before that, let us understand what is data science. Data science can be defined as a blend of mathematics, business, tools, algorithms, and machine learning techniques, all of which can be finding out the hidden insights or patterns from raw data, which can be a measure used in the formation of big business decisions. Who is a good data scientist? A good data scientist is someone who can ask good questions. But what are good questions here? They are what, why, and how. What comes under business intelligence and analytics? It shows what has happened. Why comes under data science and EDA part, which shows why it happened. How comes under machine learning. It shows how we can predict and automate decision making systems. A good data scientist needs to be a business expert. They have to understand the business and industry sector very well and really where and how values create. They also need to be an innovator. They have to be able to see where in that business model there is the most opportunity for driving value and change, and how these changes can lead to competitive differentiation. They should also be a solution architect. They have to know how to work between business teams and the technical teams to design the solution or the intervention mechanism that you want to put in the place. And although this individual, the leader, have to be a bridge between the business and the technical teams to ultimately architect what solution is that brings put into the place. They should also be a network builder. He or she has to be able to get things done in an organization, and that typically means having a large number of very trusted relationships with senior stakeholders throughout the company. Now, data science life cycle. Let us take an example which we took earlier, the smartwatches. So these smartwatches comes under the domain of healthcare. So let's take the data points to capture the footsteps, calories, what is eaten, what is the blood pressure, what is the heartbeat range. Remember, here the domain says these are the things that you need. And that's why domain is important because it tells you how you know you have collected the important points. Next step is of applying statistics to understand data points and come up with the insights, such as health is going good or health is going bad. We use statistics. Next is we are programming it to give me these reports on the day-to-day basis, and I will use to analyze the performance of some XYZ person. So that XYZ person will see some dashboard in his smartwatch, which will help him to get its day-to-day performance. And based on that, the guy will make some strategies. Like tomorrow, I will wake up half an hour earlier and run 30 minutes more so that I can cover up my footsteps or else calories. So this is how the life cycle works. Now this diagram represents where the information comes from, what it represents, and how it can be turned into a valuable resource for strategic decision making. Now, job roles. What are the important job roles in this field? First, data analyst. Responsible. It is responsible for a variety of tasks, including visualization and processing of massive amounts of data. Data engineer. They build and test scalable big data ecosystems for the businesses so that the data scientist can run their algorithms on the data systems that are stable and highly optimized. Database administrator. This job is pretty much self-explanatory. They are responsible for the proper functioning of all the databases and of an enterprise and grant or revoke its services to the employees. Machine learning engineer. They are very highly in demand. The job profile comes with its challenges. Although we can say they are having a good in-depth knowledge, but they also should know all the powerful technologies such as SQL, REST APIs, etc. They are also expected to perform A/B testings and build pipelines, and they should also know a variety of machine learning algorithms. Data scientist. They have to understand the challenge of business and offer best solutions using data analysis and data processing. Data architect creates a blueprint for data management so that the databases can be easily integrated, centralized, and protected with its best security measures. Next is statistician. Has a sound understanding of statistical theories and data organizations. They help to create a new methodologies for data engineers to apply. Business analyst. We have a good understanding of how data oriented technologies work and how to handle large volumes of data. Understanding or the separate high value data and low value data. Now, the four components of data science. Understanding the structure of a typical data science project is the first step of the process of building your internal data science practice. Missing any of these core components of data science can result in the failure of your efforts to realize any true business value. So, what is data strategy? Developing a data strategy is simply determining what data are you going to gather and why. It requires you to make the connection between the data you are going to gather and your business goal. In the end, the effort you put in gathering the data as well as the formatting it correctly and getting rid of the garbage data that doesn't serve your business goals is important. Now, let's understand data engineering. Data engineering is about technology and systems that are leveraged to access and organize the use of the data. Here, you are establishing a data system, then creating a data pipelines and endpoints within the system. Data engineering requires in-depth understanding of a wide range of technologies and framework as well as how to combine them to create solutions that enables business process with data pipelines. Now let us understand the data analysis and data models. This is the heart of a data science. It's where a lot of what we associate with data science happens. Computing, maths, statistics, domain like healthcare or finance. It uses the data by performing some task like to describe, extract insights, or to make predictions about a service, product, person, business, or more likely a combination of them. Here, the data analysis and mathematical modeling is the computing power, the incredible amount of data available, and some new algorithms. Remember, in the addition, now that we have an access to more advanced computing power and more advanced data, so we can build many existing mathematics and statistics that could not be utilized because of the computational power limitations we had earlier. Now let us understand the data visualization. Visualization is not just about talking the data analysis and presenting it correctly. Sometimes it involves going back into the raw data and understanding what needs to be visualized based on the needs and goals of both the user and the operations. Here we communicate the findings with the key stakeholders using plots and interactive visualization. Now let us understand the operationalization. Operationalizing is really about doing something with the data. Someone or occasionally a machine has to make a decision and take an action based on the math and computing that has happened. It is in the end goal when it comes to applying the data science. Treat it exactly as though you were creating a product feature because, from a practical point of view, that's what it is. So, let's go deep into data science.